Okay, we are still on momentum and impulse, and today we will be looking at elastic and inelastic collisions. Let's first look at elastic collisions. Let's look at elastic. Let's look at elastic collisions. During elastic collisions, during an elastic collision, kinetic energy or kinetic energy is conserved. The second thing, momentum is conserved. An elastic collision is defined as a collision in which kinetic energy is conserved. Just say kinetic, or in which kinetic energy is conserved. Momentum is conserved in both inelastic and elastic, so it doesn't really matter that much. In other ways, it simply means that the kinetic energy before collision is equivalent to the kinetic energy after a collision. This is what this statement here means. It simply means the kinetic energy before collision is equivalent to the kinetic energy after collision, and momentum is conserved. Okay, let's now look at our inelastic collision. Now let's pay attention to inelastic. Let's pay attention to our inelastic collision. This is a very interesting one. The first thing you should know in this one is that kinetic energy is not conserved. This is the first thing you should know. And what does this mean? It means that the kinetic energy before collision is not equivalent to the kinetic energy after collision. It's not equivalent to the kinetic energy after collision. And then another important thing that we should know is that momentum is conserved. Momentum is conserved. This is another important thing that we should pay attention to. But let's look at other traits which makes an inelastic collision. The other trace that makes an inelastic collision is a change of shape. After collision. Let's say two cars collide and they both change shape due to the collision. That's an inelastic collision. There was energy lost. Or they make a sound during collision. When cars collide, they make a sound during the collision. This means it's an inelastic collision. They make a sound. That energy, kinetic energy, is now released in the form of sound. And they also give off light. Kinetic energy is now released in the form of light. Another thing, they heat up or just become warm. Energy is now released in the form of heat. And the last thing is that they stick together. That's the last thing, is that they stick together. Okay, let's now look at an example. Let's look at this example. A 2 kilogram pool ball A is traveling at 1.2. It is traveling at 1.2 meters per second east, strikes a second 0.2 kilogram pool ball moving at 0.9, not 0.5, rather 0.9. This here it's supposed to be 0.9, not 0.5. Yeah, moving at a 0.9 meters per second. Ball A moves at 0.5 east after collision, and ball B moves at 8 meters per second east. Determine the collision, if the collision is elastic or inelastic. Okay, let's just do this in a simple manner. We will have the sum of the kinetic energy before collision, initial kinetic energy, which is equivalent to half the mass of ball A and the initial velocity of ball A squared, plus half the mass of ball B plus initial velocity, by initial velocity of ball B squared. This will give us half. What's the mass of the ball A is 0.2, and the initial velocity is 1.2 squared. The reason I do not consider the direction in this case is because direction is only carried by velocity, and this velocity is being squared, meaning that by default our solution will not have direction. And if our solution does not have direction, it means kinetic energy is a scalar quantity. I've explained these scalar things on the first lesson. You can go watch the first lesson if you did not watch the first lesson on this playlist. And then we will also have half the mass of the second ball is 0.2 also, and the velocity here is 0.9 squared. So here I will have 0.144 joules energy plus 0.081 joules, which is 0.225 joules. Now I know that my initial kinetic energy, the kinetic energy before collision is 0.225 joules. This is something I know, I'm 100% sure of. It's something I've calculated, that before collision it was that. Now let's look at after collision. After collision I will have the same ball A, final velocity of ball A, ball B, final velocity of ball B, both squared. Now I will have half the mass of ball A, which is still 0.2, and now the velocity of ball A is 0.5 squared plus half of the second ball, which is 0.2, mass of 0.2, and my final velocity here is 0.8 squared, and my answer here will be 0.025, and my answer here will be 0.0641, which gives us a 0.089, an answer of 0.089 joules. And if we pay attention, our initial kinetic energy before collision is not equivalent to our final kinetic energy. It's not equivalent to our final kinetic energy, and this gives us the conclusion that the collision is inelastic. Because why? Energy was not conserved. And this concludes our lesson.